for my contribution. Unfortunately, I this week I could not stay longer, and I would have liked to have more time with you and more preparation, especially. Anyway, I did my best during your break to write a few diagrams to help to explain the concept we are going to see now. Well, without waiting further, I will go to the program. Okay, so we at the just before we talked briefly about Linux systems. I don't think we need to talk further unless you have specific questions. So I will let you express me if you want us to talk about further about Linux systems, or if you have specific questions. If not, I suggest that we'll let me share my screen. Sorry.
Any specific questions on Linux?
Suggest that we switch. Okay. Let me get out. Okay. So we were stopped here in Linux system. Is anyone has some questions or would like to make any remarks or anything to say or to ask regarding system side, or either generically or in the specific HPC context, or something to ask about distributions, Red Hat versus Debian, etc., etc.
Hello? I don't think any questions or comments now. For now.
Okay, great. So I will just make a very short summary before going to the next step. Regarding Linux systems, there's not a lot there's a lot to say, obviously, but in very short, I would say it makes no doubt that you will use indeed a Linux or a Linux kind of or a Unix-like system in HPC context. And more generally speaking, I would say that as a system engineer and system architect, solution architect, I would strongly recommend you, even on personal side or for your personal knowledge, to go for Linux. It is incredibly versatile, and it is more than just an operating system. It can act as an entire network operating system. It is actually one of the most advanced network stack, full network stacks that you can imagine. Well, to say it shortly, since networking is one of the things I'm mastering most in Linux world, I would say there is basically no known feature that cannot be handled in the network domain by a modern Linux kernel. So I think it's simply said. You can also check BSD, which is also a brilliant OS and kernel to do a lot of advanced things. But once more, I would say that always consider Linux-based solution, even if you want to purchase an already made appliance, or if you feel cool and strong enough to build one by yourself. But in any way, it will be something that will provide you with an unrivaled expertise and knowledge of what you are doing and network in general, even if you are not a network specialist. So I won't stay too long on this one, but just to give you for another small example, uh, during I would say 10 years ago, I was still working for offshore industry, and we had to manage a few seismic vessels, um, which were using satellite internet link. So I can tell you that each bit of the bandwidth was counted, since it's very precious, because on this satellite link we had all the voice, we had all the data for the information system and everything for the guys on board, their personal mails, their stuff, and whatever. Uh, so it was sometimes challenging to qualify some application in regard of latency or other constraints, or let's say outage that can occur on a moving on a moving thing. So you are not in this specific context, but you can be in a similar context where you will want at some point to qualify some application before going for real. So let's say, for instance, you are in charge of studying something, a new project, something like that, and you are challenged to to, to characterize how a given application will behave before that you will deploy it on over a one link, for instance. Okay, one. Everyone is familiar with what is WAN, WAN, compared to LAN. I think so. If someone is not, just raise your hand so I can know. So as you know, one can be sometimes tricky when you want to implement a link from an institution from another. In your context, for instance, if you want to centralize, at some point you will maybe aggregate your clusters. So you will get one cluster for Nigeria, for instance, one for Benin, one for our friend from Senegal, for Ivory Coast, or I don't know, whatever. Or so you will be at some point facing the problem of how will behave an application within a slow link or a potentially outaged link. So this is something that will happen probably in your engineer life, when you will be called to build a design, or to lead a project. And for such use, generally we use what we are calling a network simulator. What is a network simulator? It is something very full-featured, I would say, that permits to simulate in a very precise, realistic way, I would say, some links locally. So it's like a box. You enter, you have an entry point and an output, and you put that in serial, I would say, between two equipment, and it permits you to simulate how your application, how your shells, how your whatever will act through this particular link without doing for real. And you can simulate packet lost, you can simulate latency, you can inject latency, you can cap also, do some capping on some streams very finely, with an incredible level of granularity. And this kind of equipment are well known and sold for incredibly high price as in the form of appliances, of hardware appliances, as some firewalls can be also, some kind of firewalls. Especially, I'm thinking of sorry, I forgot the name. Palo Alto. Palo Alto is a well-known manufacturer for all kind of intrusion detection system or intrusion prevention system or full-featured firewall, and all this stuff are sold as appliance, which is a mix of hardware, of silicon, and a mix of software. And under the hood, if you look, most of them are using either Linux or BSD. And this is things that you can do by yourself. It's just a matter of work. And if you can do that, you will have a great mastering of what you are doing and you will save a lot, not a small, a lot of money. The same goes for storage, the same goes for a lot of things. So don't believe I focus only on the economic aspect within going for open source. It's also a problem of quality, of code quality, of product quality, and of functionality. If you buy an appliance, you will pay for this appliance. And when you want to add some new features, the manufacturer will say to you, okay, your support period is expired. If you want to get an update, you will have to pay for that. If you don't, you are just basically stuck, and you have to deal with that. To deal with flow, with security holes potentially, and so on. That's how a lot of things are are going here in our industry. So the more you will master, the more you will save, and the more you will manage your infrastructure with a lot of ease and very safely. I mean. Okay, so that's it for Linux. I could talk for hours about this subject, or I would say days, but just keep in mind that a lot of things can be accomplished in the software way, and this is a very clear trend, I would say, this last year, especially in the storage and in the network industry. I would say the more it goes, the more we take out the intelligence, the added value. We take it out of Silicium, and we just keep Silicium for silicon for getting the data inside or outside, but that's it. Because software are just too much powerful now, and we have the power to make them work. But you have just to keep in mind that there will still, obviously, there will still be some hardware, and in some cases, a dedicated hardware treatment is much more efficient than software. This is generally speaking. When it comes to signal processing and things like that, nothing can beat hardware. Nothing can beat a DSP in some cases. If we are talking of signal treatment, for instance, or I would say voice over IP or things like that, at some point, some dedicated hardware silicon will be much more efficient since it will offload your main processor from this task. To give you an example, I will not go further, but you have some DSP, for instance, for some digital signal processor that will run at let's say something like 30 megahertz, which is ridiculously slow compared to some other modern processors, but they will act much more efficiently than a generic modern processor that runs incredibly uh, more faster. For good reasons, it's the DSP as the ASIC, which is the heart of your switch or the heart of a lot of embedded systems. An ASIC is an ASIC or FPGA is a kind of burned-in processor, of specialized processor. So just keep in mind, guys, that your processor, your CPU is something very, very, very generic. It can be almost as much efficient as an ASIC, which is specialized for some task, but at some price. It means it won't be able to do anything else, and it won't do it as much efficiently as a dedicated processor can do. That's why we are doing GPU and dedicated. If you compare, for instance, a GPU and CPU, it has just nothing to do. GPU is much more complex than a CPU. It has incomparably much more transistor density, and so just as a final word, just choose the right tool for the right job. Okay, let's go further. If not, I'm afraid that will overlap too much. We'll jump straight to virtualization and containers, and then we'll go back finally to automation and deployment. So there's a good reason for that. It's to prevent if we take too much time on virtualization and containers, and you guys are already full, I would say. It won't be a big problem because all you will see in automation and deployment will be written and practiced by you guys during the training with Benoit. So we're gonna now focus on virtualization and containers. This is a pretty important subject. I don't know how you are comfortable with that or not. The objective of this section is to make you comfortable with what is a virtual, I would say, virtual machine, and what is the virtualization concept without entering too much in detail and being too much specific. But I will just provide you with a few tricks and maybe some advices when it will be time for you to consider a choice for a virtualization solution. And we'll talk, if we can, very briefly of other kind of virtualizations. I mean, not only applied to servers, if we can. And then we'll talk about containers, since it's a pretty important subject. And if time permits also, and if you are interested, we'll discuss about containers orchestrations, and maybe Kubernetes and so on. I maybe you will notice that I removed the cloud part since I had to make a choice. But if you guys are interested to discuss, or if you have questions about it, please do not hesitate. Uh, I would like that you guys take the most of this training as much as possible. Okay, so let's go for virtualization containers now. On the left side, I represented what I call a physical host, or you can also call it a bare metal host. This is a traditional server, the equivalent of your laptop if you want, but it's anything else than a normal machine. Here we are considering servers, but you can you can compare it with your own computer, no problem. Okay, so as you can see, we have on the top an application layer, OS layer, and hardware layer. And beyond this hardware layer, we have I tried to represent two hard disks and two network cards, since let's say it's a server. So the hardware layer, I think it's obvious for everyone. It's all related to hardware. Also, I didn't represent it CPU or memory and so on and so on. But this is what I call hardware layer. Okay. OS layer. Here you will find your Linux, your Microsoft Windows, your FreeBSD, your iOS if you are running on Cisco, your Android if you are running an Android device, etc., etc. On the application layer, here you will find the applications that are running on top of the OS operating system. So here you have your Zoom, here you have your web browser, your Office suite, and whatever you want. Or if we are talking of a server, uh, I would say hardware layer will be standard server, OS layer will be a Linux, for instance, can be Red Hat, Debian, whatever. And application layer will be either a daemon or it can be a shell command such as ls, or either graphical or text application, whatever. Okay, so I think this concept is clear for everyone. So what is virtualization and why virtualization? Okay, if we narrow to server virtualization, it is the definition, best definition for me is the concept that permit to execute virtual machine on one or several virtual machines on one physical machine. This is what we call consolidation. And we aim to say when a very common case when you have a project for virtualizing your existing hardware, or you are required by a customer to do what we call P2V. You are doing actually a physical to virtual. I think you guessed it already. So when we talk P2V, it consists to take a hardware machine and convert it to a virtual machine. There is a lot of benefit to that. First, first one is consolidation. So you will consolidate on one hardware. You will consolidate a whole machine. The thing is good because in the past we always tend to put maximum as much as the hardware resource could permit it to load the machine to justify that we bought a server. So okay, we have to 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 take the most of it, I would say, since it can handle that. So let's put the loader where it can and where we put our effort. So this is good, but this can be very costly, and also it remove some granularity. I mean that you are forced to put all your eggs in the same bucket. You know what I mean? It means that if you have several services, let's say you have a web server or mail server, storage server, or whatever server, which are running can be running on different OSs or and have different IPs, have different storage, etc., etc. So this is cool since you have granularity. You can put one in maintenance and say, okay, I have the others working. But if you want to do that with physical machine, you need to have a lot of physical machines, and it can cost a lot at the end. So that's why we for sometimes I mean at sometimes we used to consolidate service on one physical machine. And then this problem appeared, and so this is where the virtualization came very, very handy. Since on one physical host, you could slice it using virtual machines that permits to have a lot of granularity at the price of one physical host, and then takes the best of this physical host, because more also another point on physical machines is that you rarely used all the power of your machine. It's very rare that a processor is always used, uh, especially even for a server. So I won't go in detail unless some of you are interested to know how the what we call the hypervisor is doing that. But globally speaking and roughly speaking, for those who just want to know how it works under the hood, I would say simply just that this is TDM, what we call time division multiplexing. So TDM is a very common concept for the ones that are familiar with network or signal processing. But technically speaking, it consists of taking, it's as if you take a very small, very small knife that could cut time in a very short slice. Let's say if we talk in gigahertz, let's say 1 power, sorry, 1 minus 10 power 12. So I don't know how to say it in English. It's 1 billiard of a second. Okay, so 1 second, 1 of our second for a CPU is like an eternity. It's like I can say 100 of 1,000 years. 1 of our second. So in between this interval, it can happen a lot of things. And what the hypervisor is doing is slicing time and slicing access and distributing equally access to resources in a very short time, giving the feeling to the host machine that it is only it is alone on the machine. But at some point, if you take it technically speaking, at some point, a given hardware can be accessed by only one machine at some time. And this is what happened, but it goes very fast. This is TDM, basically, time division multiplexing. It is one of some numerous multiplexing methods that exist in IT. It's very used in telecommunication, for instance, when you are using what we call a digital line. You say ISDN in English or RNES in French. You are using time division multiplexing, since actually all your words are cut and put in a small bucket, and the next word from the other person is cut and put in the same bucket, etc., etc. So everyone has a very short period to put his data on it, and everything is demuxed at the other end. And that's how we can trunk, as we do in network. We can trunk a lot of communication simultaneously or almost simultaneously in the same pipe. Okay, so let's go back to virtualization subject. So now you know why we wanted virtualization and how it works. I would say it could be ideal, um, unless if you consider that, okay, now you have a lot of granularity, you have put all your physical hosts, you have converted them using P2V as virtual machines. So you have one virtual machine here, another one here, another one here. So you could say you are in a, in a kind of ideal world. However, there's another problem. If you look at the second figure, you can see that you have a big SPOF, because the SPOF is the bare metal hypervisor itself. Because you actually you put all your eggs in the same bucket as well, even if you are a granularity because you made virtual machine, but you are sitting on only one machine. So potentially on only one storage. That's where you start to have to get in trouble. So that is why we are using when it comes to to virtualization, you must introduce a shared storage and an orchestration layer. That is the key. It means that by using a shared storage and an orchestration layer on top of it, you will use, uh, we'll say, at least 3 hosts. I will explain you why after, to avoid what we call a split brain situation, and to get always a quorum. But I will explain that just a bit later. Unfortunately, I had not time to make a proper graph for that, but you will understand, I hope. Uh, I mean, if you put one virtual machine on one hypervisor and others one, you will be happy, so because you will have granularity. Also, everyone will have its own IP, its own storage, etc., etc. You can reboot one without affecting others, apply software update, etc., patch, reboot, whatever, put it in maintenance, with only affecting a given service without affecting all the services running on a whole machine as before. But you have another problem is which will occur when if the bare metal hypervisor itself is outdated. What if you lose a storage here? What if you lose a network interface? What if you lose, I don't know, if the motherboard is destroyed? But basically, you will lose all your VM instantly, at least access to those VM, which is not cool. It is not what we like and what we want, at least not what your customer want. So I would say to address that, the elegant solution is to make use of at least 3 hypervisors and get those 3 hypervisors to have a common storage. This is the key. Virtualization is pretty cool if you have a pretty cool storage as well. Okay. Unfortunately, I do not have more time to go in detail and to tell you why. But let's go further to orchestration and HA and etc. And I will come back to storage consideration when it comes to go for virtualization. Okay, so the solution for that is obviously to use more than one hypervisor. We'll use at least 3 for a reason we'll explain later. But let's say, okay, we will use, okay, 2 hypervisor. So here the situation is very different since, okay, we have our VMs. Let's say we have 3 virtual machines. So we run on 2 hypervisors, but only a VM will run at a given time only on one hypervisor for sure. The other one can run either other VM or just stay waiting for nothing, or waiting for the other to fail to take over the VM. Or we can balance. We can balance VM between the 2 hypervisor. All of that is managed by an orchestration layer. So typically, VMware is one of the most famous. It's not especially the one I will recommend. Why it is brilliant, I can tell you. I worked for years with VMware product, vSphere, ES6, and so on. This is brilliant product. But they have a serious competitor, which its name is Proxmox, which I would definitely recommend you. Proxmox is, I would say, the choice when it comes to open source virtualization. It's not a virtualization itself, a virtualization engine by itself, but it wraps, without being too much technical, it wraps a QEMU, which is itself making use of a kernel built-in virtualization feature, which are called KVM, which stands for kernel virtualization. Don't be confused with KVM, with what we call keyboard, video, and mouse. This is another subject. When you call KVM in the hardware, it stands for a console with integrated screen, mouse, and keyboard. But when you say KVM in Linux or kernel or virtualization context, it stands for what we call para virtualization. It's a special kind of virtualization proper to Linux, which is particularly efficient. Since it makes use, well, it's expose the hardware to VM in a different way than VMware does, for instance. You can also consider Xen, which is a brilliant hypervisor. This is actually this is for those who knows about Citrix. This is a underlying virtualization layer of Citrix, and it has a free version that you can use in production. The name is a Xen server. So, but definitely, if you ask me for a generic virtualization solution, I would tell you, okay, go for Proxmox. Proxmox is brilliant, really. It's really a nice product. And purely, I mean, it's really an open source, but it's also have a commercial support. So it can be an answer for your customers that require, okay, we want something with a proper commercial support. Yeah, okay, Proxmox is a choice for you. And if you have to go for VMware, VMware is excellent as well, but it's not the same price. That's it. But best is to practice. I just enumerate a few generic concepts. So, okay, now you know. I would say, okay. I hope it's clear for you this orchestration layer on top of virtual machine, because this is very important. For a very small organization with or for yourself, for your personal lab, it is acceptable, I would say, to have something like one hypervisor and one storage, as long it is robust enough, I would say, redundant enough. Mirroring would be a minimum, but I would strongly recommend to use at least 2 or 3 hypervisors, and this will require shared storage. And I take this opportunity to make just a reminder for our storage consideration, a very important storage consideration. This must be also understood. When you will go for shared storage, you have 2 choices. It's whatever the virtualization solution you will consider. Let's say, okay, Proxmox and VMware, for instance. When you want in VMware terminology, this is called a data store. Okay, a data store in VMware terminology is a repository where you will store your virtual disk, your virtual machine, your virtual stuff. Okay, so all your data, which is not virtual, it is hosted on virtual disk and virtual machine, but the data is not virtual. Okay, also all your important stuff will be stored in the data store, and this is very important to make the right choice when you come to configure a virtualization architecture, to make the right choice for the data store. Because roughly, if I consider VMware, you have, or even Proxmox, you have 2 choices, or 3. You have local. So if you have more than one hypervisor, you won't be even concerned. Okay, you need a shared storage. So, okay, local data store is out. So it remains NFS, it remains NAS. So in other words, NFS or SAN. That's it. You have no other choice. And your choice will have an impact, because Without entering too much in detail, just bear in mind that if you, for instance, in case of VMware, VMware is using its own file system, which is called VMFS. And VMFS is a special file system that can handle a lot of cool things, including hot resizing, including concurrent writing between two different hosts. It has been made for the beginning. It's a cluster file system. VMFS is a cluster file system. So there's a lot you can do when you are using the built-in VMFS, and a lot you cannot when you are using NFS. For instance, what we call, I don't know if for you, if how familiar you are with virtualization, but there is a concept. I will take you a simple example. Uh, when you create a virtual machine, you will create virtual hardware and so, okay? Um, let's say for a virtual disk, when you will create a virtual disk, it will ask you, okay, would you like to create a thick disk or a thin disk? Or it can take some other names, but in VMware terminology, this is how they do. It means, okay, you want to create a 10 gig virtual disk. It will ask, would you like to create a 10 gig already provisioned 10 gig virtual disk, or would you like to create disks that will grow with use? In the first case, you will provision the wall space. In the second case, you will provision the space as only as long as you will really use it. So there is different choice to do depending if you want, if you of your storage strategy of how you will have in real for storage. For let's say you can allocate space that you don't have, for instance. This is very powerful for that. Let's say you want to say you will create a virtual machine. You have only 100 gig. You want to create two virtual machine which with 100 gig virtual disk. This is possible with a thin allocation. It will just instruct and say to the virtual machine, okay, you have a 100 gig disk, but the storage will not be really allocated. So this is something you have to know, and this is something you will have to consider when you will go for more than one virtual machine and you will have to do orchestration. Since with orchestration, you can balance your virtual machine between one hypervisor and another. This is called virtual vMotion, virtual machine motion. It means that a live machine, without stopping it, it can move from a physical hypervisor to another. This is brilliant. So you can virtually move a machine from an hypervisor to another. It will take over the virtual machine from a given hypervisor, for instance, if you want to put it in maintenance and so on. But the thing is, if you make the choice of NFS instead of using a SAN approach, then you will go for an issue. I mean, it will work, but for a machine that you provision, let's say about 100 gig, you will have to carry on this 100 gig for real, since thin allocation cannot be done on NFS. So the result will be that the file will be 100 gig for real. And when you want to go for vMotion, for storage vMotion in VMware, it will not be the same load to transfer 100 gig or 1 terabyte than to transfer only the real data used. So this is a concern. This is something you want to pay strong attention. Okay, so we're ready made 1 hour. I will go for the next and share my screen again. Is there, before we going further, is there any questions regarding virtual machines, or is there anything you would like to ask?
Camille, I don't think
Yes.
there are any questions. No questions.
Okay. All right. So we switch to. Sorry. So now we are switching to containers. Question: is any one of you is already experienced it with containers? Okay. So I will go
Hello?
for a presentation.
Yes, we
Yes.
have experience with containers.
Okay.
Not
Are you?
everybody, not everyone, but a couple of us have
All
experience.
right. A few of us. Okay. So I think this will gonna be familiar for you, but maybe it will also be a useful refresh. Okay. So we explain what is a virtual machine and what are the I would say the challenges inherent to the use of a virtual machine. Now we are going to talk about containers and what is a containers and why we are using it and how it differs from a standard virtual machine. Okay. Well, first, containers. I'm pretty sure I represented with Docker host, but it could be written container host. Uh, I think most of you heard about Docker. Uh, Docker is a way to manage container, but it's not the only one. It appeared recently enough, as less than 10 years in the IT industry. Uh, but containerization, sorry, is not something really new in the IT industry, especially for the ones that are already familiar with Unix and Solaris in particular, which was Solaris doesn't exist anymore, but this was Sun, which is now Oracle Unix. It was a Unix from Sun. It was quite a nice operating system, very powerful, and it was using for years already containers. And so containers is for maybe some of you are already familiar with what we call um, uh, CH root, CH routing. Maybe I are familiar with that. It's a feature that permits in Linux distributions that permits to isolate a process from the outside and makes it believe that is alone on the machine. So, for instance, standard files such as etc host or things like that are differentiated for this process is in kind of jail. Um, and we use CH root, generally speaking, in system administration. We use it for securing processes that are in contact with the outside. So it's a kind of jail, or you can make a very close parallel with what we call in network terminology a DMZ, a demilitarized zone. DMZ. So DMZ is where you put host exposed to the outside. So it's a zone where you will, for instance, if you want to expose some hosts to directly to the internet or outside of your network, you will put it in the DMZ. So CH routing a process is a kind of DMZ for process for the network guys. Maybe it will be more speaking. While it's a generic concept. Okay. As you can see, if we are looking for the left pane, you have your hardware here, the hardware layer, the virtualization layer. So the hypervisor, which is slicing the hardware in very small slices and distribute it equally in time to each virtual machine present here. So it slices the CPU, it slices the memory, and it slices the access to the hard drive, to the network card, etc., etc. It's a kind of multiplexing, as we said, TDM, okay? Time division multiplexing. And then it exposes a standard x86 architecture in the virtualization layer, and this part is clearly written in very low level language such as assembly. Only assembly can achieve such a low level emulation. So this is particularly hard, I would say. It's a bit like if we are talking about the low level layer of kernel, or if you talk about device drivers or things like that. At least I would say even device drivers are simpler than that, since device drivers or kernel module are written in C. But assembly, for those of you that are not familiar with it, is the smaller level you can imagine in a programming language. You have nothing lower than assembly. Oh, see, yes, sorry, you have a hexadecimal, and which is a representation of a binary. So typically, you cannot go lower than assembly for sure, unless you are a machine. The assembly is just a mnemonic which is representing a mnemonic. I hope it makes sense for everyone. It's just a symbolic representation with a human word of hexadecimal instructions. Okay, and keep in mind, I should have written that, but keep in mind that 2 hexadecimal are equal to 2 binary quartet. Okay, if I write FF, it is equivalent to write 255 in decimal, which is equivalent to write 1 8 times in binary. Okay, this is fundamental. So you have to understand that it was just a parenthesis, but this is very important for network understanding. I would say your best friend is the power of 2 and IT in general. Power of 2 is almost everything. We'll take a short example after I will close this parenthesis. Let's say you ask me, okay, Camille, would you mind to to set up VLAN number 5000 something, I can say for you for sure you are wrong. Say no, I can do it. I cannot do it. Why? Since a VLAN cannot go over 496. And it's very simple to understand because the VLAN is coded in the Ethernet frame is coded on 12 bits. So, okay. So 2 power 12 is equal to 496. That's why you cannot have an IP address that go beyond 255 because it's coded on 8 bits. Using 8 bits, you cannot go further to 2 power 7, 2 power 8, sorry. So that's why I tell you power of multiple of 2 should be your best friend. It can save you a lot of time. Don't even try, for instance, to address more than 4 gigs of memory on a system that has, which is on a 16-bit system. You cannot even imagine to go over 4 gig of RAM because of 2 power 16. So it can save you a lot of time when it comes to design and troubleshooting. Anyway, we'll go further to avoid losing too much time. So it's very important to understand this virtualization layer and Linux kernel LXC layer if you want to play with virtual machine or Docker host. This is something you want to be familiar with. Okay, and the thing to come back on Docker, after I will tell you also why Docker has been so much popular. There is a very good reason for that. But from the sysadmin point of view, or from the infrastructure guy point of view, I would say if you look at these 2 figures, you will see that on the left pane, you have a fixed footprint, which is the OS layer. Okay, which means that if, for instance, as we did for virtual machine, why did we did virtual machine? To have this granularity. Okay, so I can have, for instance, as we said before, I want to have a mail server, a web server, a storage server. Each of them, I want to have them on its own virtual machine. To have granularity, if I want to take one down, I don't take the whole system down. Okay, that's fine, cool, nice. Those 3 systems, as I'm a reasonable system engineer, I decided in my design, I decided to run them on Linux and preferably on Debian. Okay, cool. Now, if you look at that, you will see that on this figure, I will load 3 times the OS layer, which is normal since I have 3 different machines. But do I need to have those 3 OS layers? This is a fixed footprint that eats some memory, that eats some processor time to execute, and I don't need that twice or a third time. We don't want that. We don't need. We just need our application to be separated. That's where containers comes very handy, since it's a kind of CH root, but much more evoluted. And the thing, if you look here, it's a container with embed also its own application and its own library, sorry, which is pretty cool. Since all the common library, it will get them from the system, and all the specific libraries that it properly require will be embedded in the container. This is pretty cool. So we consume only what we need. All the common stuff is on the OS layer. It's enough for us. We don't need to virtualize a whole kernel, etc., etc. You see the difference here? Each VM has its own kernel, which consumes memory, which consumes CPU time, etc., etc. So you can get an incredible increased density and make a much more clever use of the resources of your machine with a container rather than with a VM. The first step is the bare metal. You consume all for nothing. The second optimization has been virtual machine, and it's still recommended for some cases, but there's not a lot where a container is not suitable. But the ultimate level of granularity, I can say, is container. You cannot be more granular, I think. You can virtualize, isolate only one process. This is something that was possible with good old CH root, but it is not exactly the same. Since a container can embed also all libraries and also define namespaces, which means that really the process is really alone in the world. It feels itself alone. If you are familiar with process management, if you type PS in or PS AFX, for instance, to see the process arborescence inside a container, you will see that it has a new process arborescence. It has its own init, etc., etc. So it's not even aware of it has its own PID, etc., etc. This is namespace. So namespace is a generic concept anyway, but namespace is applied to container has really a specific sense, and it applies not only on file system, but on every resources the OS can expose to an application. So it's really, really, really brilliant. I can tell you it's the future. There's still some room for virtual machine, but less and less. For sure, container is brilliant. But you will have this, there is a few caveats with container. It's very ephemeral. Okay, so it's a container, the rules, a container must be stateless. A container must be volatile. It can be destroyed and recreated at any time without losing nothing. So the container is spawned. Once it's finished, it is either destroyed or stopped, but you won't want to store anything in a container, especially starting with logs. So if you have logs or whatever, you have to treat them, I would say, as an event and forward that outside of your container. So every interaction with the outside will be done through a dedicated mapping, I would say. Okay, I guess you guys are already familiar with NAT, network address translation, right? Okay, we'll take a
Um,
very. Hmm?
yeah. There is a question, Camille, but not everyone
Okay,
is familiar with not.
okay.
Not everyone. So here is the
Okay, first I
question.
will I will I will answer a question first. Mm.
Okay, thank you. You said that a container is volatile.
Mm-hmm.
So how can we make consistency or
Uh,
persistency of
Persistency,
everything?
yeah, sure.
Yeah.
Yeah, very good question. Well, the best example, let's say, okay, you want to containerize a given daemon, a given service. Okay, you want to get it in a container. But as for each service, we like to have these logs. We want logs. We love logs. We need logs. These are precious. This is very precious for troubleshooting. So your question is very pertinent. Where do we store what we produce with a container? The answer is using a mapping which will instruct, which will be the gateway from the container to the real world, to the real file system. Hmm? And this mapping will permit, and it will is going to be the same each time you will want to cross the namespace, the isolation layer, you will need a kind of mapping. So for storage, to answer your question, this is a mapping as you would do for a bindment, for example, if you guys are familiar with that. It's very simple. It's you say, okay, slash Toto is equivalent, a kind of link. You can make compare it to a symbolic link, maybe if you're more familiar with that, or a pointer for C coders. I don't know what is most appropriate to give you. So this is how you will want to treat that. Another very common example is a database. For instance, a database is producing data, or it can be read-only also, but at least it can access data. And this data must not disappear from container when it's stopped or when it's restarted or recreated. So we'll use mapping for that. You can have as much mapping you want. Okay, you can have one for log, one for, it's recommended to have separated mapping. Yeah.
Hello.
Yes,
Another question.
sure.
Uh, since you can connect the container to the host,
Mhm.
can multiple containers to be connected to a same space in the host?
Yeah, are you meaning for network or for something else?
Let's take the database example that you gave.
Okay, for file system then.
Yes. Can you have
Yeah, yeah,
uh,
yeah,
multiple container connected to a same space on your disk?
yeah, sure,
Okay. Thank you.
sure, you can. Yeah, yeah. Obviously, unfortunately, I would say, rather fortunately, there is no reason for you not to can. So this is a very common scenario. Why you have yes, the key with containers also is the word that we did not evocated yet is what we call microservices. Microservices are a bit the opposite of monolithic application, monolithic services or daemon, or monolithic application, I would say. Imagine an application which is completely monolithic. It means which is built around one service, one big service, which spawn other child processes, for instance. If for some reason you want to scale it, okay, you are required to scale it because you must face an unpredictable load. Okay, you know that your application can be suddenly loaded, but you cannot predict the load, this application load before, and you know it can happen, and you have to respond to it. You have to absorb these peaks, these spikes in the load because you have a lot of users, and you cannot say at which time you will need that. So here containers and microservices are very, very powerful. So this is an answer to that because a monolithic application will have no other choice than using a vertical scaling. If you remember yesterday, we talked about vertical scaling. It consists, if you have monolithic application, so you can spawn it on different machines or slice it in different parts to give more power to a certain part. So by using microservices, you will slice your application. It will be rewritten to be in different modules that will execute on containers. So if, for instance, only a part of your application is overloaded, you will just reinforce and put more power on this part. You know what I mean? And you will get this horizontal scaling capability, which means that you will spread the load on different Docker hosts. And the orchestration layer will help you for that. There is an orchestration layer for traditional virtualization, and there is an orchestration layer for microservices, for containers. So historically, the most common containerizing project solution was Docker, and is Docker, I would say. Um, and Docker came with an official orchestrator called Swarm. And Swarm is very powerful. If when you come from traditional virtualization world and you set up a swarm, you say, "Whoa, this is powerful." Especially for those which are involved in operations that are in front of customer, or in front, I mean, of clients, not customer itself, but I mean in front of load, because it permits to have a very high level of resiliency. It permits to make elegant scaling. It permits to update on the fly. With container, it brings you an even more powerful level of flexibility that you don't have with a virtual machine. So Swarm was already brilliant, I can say. During the time, there has been other orchestration solutions, such as Mesos from Apache Foundation. Mesos is very powerful, but it's very complex. You have also Consul, which is a brilliant solution, but it is pretty complex to use. At least it takes some time to be confident with. And then, as for a few other things, Google came and put everything. I mean, I made everyone agree with their own solution. I mean, since years ago, Google is using containers and was using a very powerful orchestrator called internally called Borg. It was called the Borg project, and Borg was basically what makes Google works. Because you guys know that even for maintaining only the search engine, you can imagine the incredible load that relies on Google's shoulder. But you must know that Google is not only the search engine. When you go to YouTube, you are on Google. When you're using Google Drive, when you're using Google Analytics, and every kind of API that are consumed by other websites that are using Google under the hood, you don't even know. It is API. It is a REST API. So you are consuming service using HTTP stream. So Google is probably one of the most solicited organization in terms of load. And it is probably the most solicited infrastructure in the world, maybe with Amazon, most likely. So I can tell you that they know one thing or two about orchestration and resiliency. And what they decided is to just to offer their stuff to say, okay, we are giving our Borg orchestrator source code to the community. and it has been handled by a foundation called Cloud Native Computer Foundation, CNCF, and which is officially in charge of what has been called afterwards Kubernetes. Okay, so if you hear about Kubernetes or Cube or key 8s, written literally key, like a key letter, 8 like 8 number, and S. You see key 8s, key 3s, Kubernetes, Cube with a key. It refers to Kubernetes. And Kubernetes is, I would say, is a state-of-the-art container orchestrating solution. Well, so just so you know, but it's maybe not the simplest approach to containers. I would say the step is, for me, the logical step would be virtualization, containerization, familiarization with Docker, familiarization with Docker official orchestration tool. Then you considering Podman. Podman is an emanation of Kubernetes as well, and it's a kind of a pod, basically speaking, is a set of containers. Okay, so the atomic unit in Kubernetes will be pod. A container even doesn't exist. The smallest thing you can have in Kubernetes is a pod. Okay, compared to Docker, with Docker has a granularity of containers. It's only managed container. A pod is a group of containers, but a pod can contain only one container for sure. But one pod has an IP address, as its own namespace for storage, for memory, for whatever, and you can restrict and cap all these things. Okay. So, I mean, containers are making use of this C group kernel feature. It permits to restrict very precisely, as even at a bit level, what a process can consume in terms of whatever you can imagine, whatever metrics available on the kernel. It means thousands of metrics. I cannot tell you the list, but everything can be kept. So this is very powerful, yeah, definitely. The last thing you asked, you ask for accessing file system outside the container.
Camille?
Yes, maybe you want to speak.
Yeah, there is a question.
Oh, sorry.
Okay. You talk about pod. That pod is a set of containers. I want to
Correct.
ask if the containers are the same or is different containers.
Can you come again, please?
I want to ask if a pod is a set of same containers or different containers.
Oh, different. Yes, it can be different, sure.
Okay.
Hmm.
Thank you.
Yeah, it can be different. Typically, a pod, yes, what it has in common is a kind of container, but that contain more than one container inside. That contain several processes, I would say, to make simple. And just to be a bit more precise regarding the question that has been asked for storage for file system mapping, we have indeed an equivalent for network. Okay, which means that a container has an abstraction, a namespace for network also. It has its own IP, its own, I would say, virtual network stack, so is able to open a port. Okay, is able, for instance, okay, I would give you an example. For instance, you can run an Nginx or an Apache or PostFix if you want a mail server or whatever you want, whatever daemon that will open a network socket. Okay, you want to run Nginx, which listen as a default on TCP/80. So it will listen in TCP/80 inside the container. Okay, but you will have a network address translation. I will explain shortly what it is. That isolated from the host, from the physical host, from the Docker host. So if you want to connect to this port, it won't be exposed by default. The port will be isolated as a default inside the container. If you want to make the container accessible from the outside, you will have to create a network mapping for that. The reason is from the outside, the container IP is not known, is not visible from the outside. It is abstracted by NAT. Okay, it's a bit NAT, to make it very simple and short. I'm pretty sure that everyone will understand. When you are using your Android or your iPhone in tethering mode, in connection sharing mode, you are doing network address translation. Okay. It means that your smartphone is acting as both a NAT router and the DHCP. Okay. A DHCP, since it will provide, using the Wi-Fi interface, it will provide private IP address, okay, local IP address using its own DHCP, and then it will route it and masquerade these IPs and forward them using its modem, using 4G, 5G, 3G, and whatever. So it means that you agree that to connect to the internet or to the outside, you need to have a public IP. So on the 4G side, on 3G side, on the modem side, I would say it will host the public IP that has been attributed by the ISP. Okay. And this IP address is translated to the other IP internally. So when a host want to use your cell phone for connection, it refers to your cell phone as a gateway, okay, as a router. It's communicate using a private IP, and then your phone will rewrite the packet. The NAT will rewrite the packet to permit it to reach the outside using the public IP that your phone is using. Okay, this is what is calling NAT. And if you are in this case, if you want to run a server, you will have to create a mapping. This is the same that goes for a container. Okay. From outside of the container, you can consider that it's a kind of public IP. This is the only one which is reachable from the outside. This is the one which is handled by the machine that runs the container. Okay. So you
Camille,
will want to, yes.
please, there is another question.
Oh, sorry. Okay.
So, so I want to know if it is possible for one container to have, for example, one application have a different version. For example, for PHP, you can have PHP version 5, version 4, and all of
Mm-hmm.
those version can be accessed for the application inside that container. And the second question is, I want to know the difference between Docker image and container.
Oh, okay. Image are specific to container. Yeah, I will go very quickly on this one. So first, to answer your question, yes, you can use, but you do not even need a container for that. PHP is a runtime, right? So PHP, for other auditors, PHP stands for I don't even remember, hypertext preprocessor. I don't remember the first P, but basically it is called what we call a server-side language. It means that PHP, it's I won't run in detail of how it is handled by a web server, etc., etc. It has no interest. It could be the same for Python or for Perl or whatever. But your question is how to host server version of a given runtime. The PHP must be seen as a runtime, as Python is a runtime, as Perl is a runtime, as all interpreted language are runtime, or Java is a runtime as well. Okay, so yes, containers can be used for that. This is an example of the use of containers, right? But you can also use environment vars for that. But containers is a very nice way to do what you describe. And it's related to your other question regarding images. An images is an already pre-built container that has been built by someone for you, or that you can build by yourself. You can start from I would say from scratch, or from an existing base image. Okay, so it will host a minimal set just to execute something. Or it can be based on Red Hat, it can be based on Debian, it can be based on whatever you want. So the idea of image, and it will permit to finish on Docker subject. Why Docker has been so much popular? Because Docker has been founded by a guy called well, whatever his name. Uh, it's someone has had a reflection. They say, okay, as a sysadmin, we have always the same, or as a developer, as a coder, I have always the same problem. It means that you are coding an application, right? I don't know if you guys are familiar with C, or maybe you have another language of predilection. For myself, I'm more a C guy. But let's say, okay, you are using a language with a lot of libraries, a lot of potential dependencies, and so on. And you will always notice that while you are polishing your applications the best you can, you are finding some difference at the execution when you execute your application on another machine than yours. And everyone that codes something has had this problem at some point. If you are primary doing scripts, it's not very pregnant, but if you go for everything that which is compiled, you will face this problem at some point. You will have some missing libraries, some problem to distribute your application, to distribute libraries, some conflict with existing libraries, or some libraries that are present but not in the desired version. So you get some troubles with your DLL for Windows, for instance, or with your libs in Linux because you are missing a given libs, or your entry point is not good, which is making your code to crash. I would say this is a very common problem. And so starting of this guys who developed Docker said, okay, it is time to write something that will permit us to distribute our application and make it to execute exactly as it executes on my own machine. So that was the purpose of Docker, not of container, but of Docker, because Docker carry on with its own ecosystem with images, which permits you to distribute your containers with the desired libraries and define very precisely how your containers will be executed. So you just need to have a Docker engine to make it run, to launch the image and to analyze it, and to run the image content. So did I answer your question?
Yes, yes.
Okay, brilliant.
I have a question. Um, which do you think is most used or most preferred between Docker Swarm and Kubernetes?
Cube. Cube for sure.
Which is
Cube.
most used or most preferred in the industry between
Yeah,
Docker
Cube.
Swarm and
Cube.
Kubernetes?
Cube. Kubernetes for sure.
Okay.
Yeah, 100% sure. Well, Cube is a level, I would say. You must be. I would advise you not go straight to Cube. Go gently first with Swarm to understand orchestration concepts. Swarm is powerful enough for most things, but if you ask me the question, okay, what is the orchestrator now, and I would say state of the art, yeah, I would say Cube. Cube for sure.
Okay. Thank you.
You're welcome. Yes, this is for virtualization and containerization microservices. I would advise you to start with Docker or straight with Podman. Or see, you can also go straight with Podman if you feel good to go. It's not bad because, but personally, I would start with container and go to or basic Docker, try play with Swarm, and then try Podman, and then from Podman go to Kubernetes. So it is the most logical progression.
Camille?
Yes,
Yeah, I didn't get the name. Where did you mean Podman or Postman?
Podman.
Pod, Pudman.
Yes. Well, Postman is also interesting for those which are practicing API.
Okay.
Okay. For those interested with API with REST, which is something that you must be aware as a complete sysadmin. I would say, you cannot ignore API, REST API. API is normally something for coders, right? But I would say as a sysadmin, also you should have uh, at the very least a basic knowledge of coding and algorithm. This is fundamental to be comfortable in your task and to better understand your customer constraints or your partners or whatever, or even more understand more clearly how an application works and why it is not working when it will come to debugging. It helps a lot.
Okay.
Yeah. And I
So
was sorry, can you remind your question? Sorry, about Podman, right?
yes, the name, the spelling.
Yes, and Postman, as I said, Postman also is interesting to consider for all those who want. It's more for coders, but it can be very useful if you want to troubleshoot an API, a REST API, because Post is one of the two methods used by HTTP. Okay, so
Okay.
if you talk about API, about REST API, you are obviously talking about HTTP, and you must know about POST and GET. This is also a prerequisite for, since all of Kubernetes is only administrated using an API. Even if some of you will say to me, okay, no, it's a kubectl. Yes, kubectl is a command for administrating Kubernetes, but kubectl is just sending API using POST and GET request. Okay. So it must be for those who are, if you are already coding PHP, you must know what is put and get post and get method.
Yes.
This is yes, this is a very basic of HTTP.
Yes. Thank you.
Okay, you're welcome. Okay, gentlemen, maybe you have other questions regarding this virtualization, or shall we make a short break maybe before going to automation and deployment?
Okay, Camille, there are more questions.
Hmm?
More questions.
Go ahead, please.
Okay, I will try. Hello.
Yes, hello.
Yes. Okay. You said that Docker is for developers that want to uh, share their application. Okay. But what container brings to HPC?
No, sorry to interrupt. No, Docker is not made for coders. It's very useful for coders. It's made for
Okay.
everyone who needs containerization.
Okay.
It's not made for coders. It's brilliant for coders. At the very beginning, it has been an answer to the eternal problem of, okay, my code is not running on your machine. It's running on mine. It's not running on this one. Same problem for on the admin side, where you say, whoa, this code or this is made against some shitty code which is not running or not compiling on my machine. What the hell is going with this code? You see? And even the developer sometimes don't even help you because uh, according to what language you are using, sometimes you don't even know which library you are referring to. If you are using very high level languages with a lot of layer of interpretation, you can be stuck by libraries that has nothing to do with your code at the first glance, I would say. But your runtime is requiring, for let's say, for instance, you have a code that breaks your PHP uh, because of a library that has nothing to do directly with your code, but which is used by PHP. See what I mean? For instance, one of the most important of all is libc, what is one we call libc. So basically, every little thing on a Linux, on a Unix or whatever, make at least one use of the libc. It's not possible to have a binary, is or only exception if your binary has been compiled as static. But if not, in all other cases, a normal binary, no, a normal Linux binary, dynamic binary, is for sure using at least the famous libc6 or libc, I would say. The current one is libc6, but this is the library. If you break libc6, you don't just do nothing. Okay, and it can be the cause of a lot of library conflict or potential installation issues and so on. So that's why it was a brilliant answer for lazy developers or lazy coders that were not or that had not enough time to take care of providing or distributing their application with an appropriate package, setup package. Okay, and it made administrators' life much more easier. If you want an example, just try to set up a complete Elasticsearch Logstash and Kibana stack by the end, and then try to do the same with containers. With containers, it's 3 lines. By the end, it's a few hours. If you're if you're doing it, if you are already comfortable, it can be days if you never did it before. So I think the question is quickly answered. That's the reason why it's very popular for distributing application, and it has been popular on developer sides. Maybe heard about DevOps. Okay, the DevOps is it's not really a function. It's a way of working. It has been a way to reconcile developer and operations. Well, if you guys don't have any other questions in regard of containers, normally you should be I already spoke with my colleague Benoit and asked him to provide you with an additional layer of of a virtualization process and Docker. So normally you should have at least another revision with, I hope, maybe more graphics to make things a bit more easy for you to understand. So I'm not really afraid. I think with what we saw today, you are ready to go safely for practical session. Now, if you guys agree, I suggest a short break just to grab coffee and take a small rest. Let's say in 10 minutes or 15 minutes if you want. We can finish with automation and deployment.
Okay, no problem. 15 minutes
Okay for
break.
you?
Yep.
15 minutes break, fine for you?
Yeah.
Okay.
Yes,
So,
fine.
okay, I see you at for your local time is 4:15, huh? Okay,
Yes, 4:15.
all right.